Alrighty, so our next problem is 14.26. It says a small block is attached to an ideal spring that is moving in simple harmonic motion on a frictionless horizontal surface. We're given that the amplitude of the mass is 0.25 meters and that the period is 3.2 seconds, and we're asked to find the speed and acceleration of the mass when the position is at 0.16 positive meters. So first let's find the velocity. Now this one is kind of tricky. We're going to have to take a given equation and manipulate it so that we can find velocity, since there's no standard equations to find velocity given these factors. However, we do have an equation that relates amplitude to velocity. That is given by amplitude is equal to the square root of our position plus velocity squared over angular acceleration squared. So first or velocity squared, excuse me. So first what we need to do is, right now we have two unknowns. That's going to be our velocity and our angular velocity. So we need to come up with something to find our angular velocity, and we actually have an equation for that. That's angular velocity is equal to 2 pi over our period. Since we're given our period, we can just go right into that. That's going to be 2 pi over 3.2 seconds, and that is 0.313. Alright, so that's our angular velocity there. And then, oh wait, I lied. My bad. So that is 1.96. That makes much more sense. Alright, so now what we want to do is manipulate this equation so we have velocity is equal to whatever this turns out to be. So what we do is we square both sides. That's going to be x squared plus velocity squared over angular velocity squared is equal to the square of our amplitude. And then we have equal to a squared minus x squared Alright, so once we manipulate the equation that we're given for amplitude, we have velocity is equal to our angular velocity times the square root of our amplitude squared minus our position squared. So now we know all of these variables here, so we can just plug that right in. 1.96 times our amplitude, which is 0.25 squared, minus 0.16 squared. And then we do that math, and that comes out to be 0.38 meters per second. And then for our velocity, we're given an equation for velocity in the book that is, or not velocity, excuse me, acceleration. Acceleration is equal to negative angular velocity squared times the position. So once again, we're given all that. That's going to be negative 1.96 squared times 0.16. And we always have this negative here simply because in simple harmonic motion, the velocity will necessarily slow down. You bounce a spring, it starts out really fast and it slows down. So the acceleration for simple harmonic motion is always going to be negative. That's why we have this negative out here in the original equation. So now we do that math, and our acceleration at this position, 0.16 meters, is negative 0.62 meters per second squared.